mean, when I was a kid, I used to get the PC, the PC magazine, and early 90s debate whether, the 486 DX2 from Intel is the one that's going to win the war against the PowerPC from Motorola and IBM. I didn't know what I was talking about, right? I was just, thought it was cool. At the end, I landed with robotics. So I'm actually a robotics guy, right? And robotics is like one of those, fashion fads, right? It's like baggy jeans. Every 10 years or so, it makes a new appearance, right? Our parents wore them in the 70s, we wore them in the 90s, and now Gen Z is wearing them, right? Baggy jeans. So robotics, is where I spent a big chunk of my career. And I learned that you have to start always with demand. So it's going to be a very short presentation. I just want to give you a quick, overview of how we're thinking about how to approach or how we approaching semiconductors from Aramco Digital side from a product portfolio. So talking about demand, obviously we're looking at Aramco as our first customer. So we're seeing a lot of demand across use cases. So we're looking at predictive maintenance use cases. We're looking at worker safety enhancement and HSE enhancement. So things like what users, I see that the slide is very interesting. So we see a lot of use cases where we need to monitor the users, the workers in plants, for instance, on the field. There's a lot of demand on the supply chain automation side. Smart city utilities, consumption monitoring of certain utilities, certain energy, water, and whatnot. Quality inspection control, industrial platforms which weave a lot of systems together, sensors together in one unified platform. And last but not least, autonomous mobility infrastructure. So we're seeing a lot of demand across the board, across these use cases, and that's where we're starting to kind of structure our roadmap. So from industrial demand to product portfolio, and our product portfolio that we're structuring right now revolves around three specific topics. First is robotics, second is IoT, and third is industrial connectivity. So I'll start with industrial connectivity because I think a lot of you have followed the news lately. We just launched our 450 megahertz IoT spectrum network in the kingdom a couple of months ago. We're building also gateways. We're building with our partners what we call XR phones, extreme reliability phones. These are push-to-talk smartphones used for critical mission infrastructure. If you go to the IoT, we're obviously looking at smart meters, asset trackers, industrial assets, environmental sensors, and rotating equipment sensors. As you can imagine, we have hundreds of thousands of rotating equipment at Aramco, and we're looking at Aramco as the big brother of all the industries, manufacturing industries in the kingdom. So what we're going to be doing at Aramco is obviously very transferable to the rest of the kingdom. And we're looking at the regionality of it. So not only the kingdom, we're looking at how can we do this not only for KSA, but for GCC and later on, EMEA and the whole world. Last but not least, robotics. Since I start with the industrial connectivity, so nobody would suspect that I'm being biased to robotics. But I think robotics is the next big thing. And again, I learned recently that robotics has got a new name, physical AI, which is pretty cool. So robotics, humanoids, a lot of people don't believe in humanoids. We're looking at it. I think humanoids is going to be the next big thing. However, also, we're looking at it from a use case perspective. How can it actually utilize humanoids to increase productivity, to reduce worker subjections to something that is not unsafe, so unsafe environments. Aerial drones, I mean, that is a big area. Ground and sea and subsea. So without further ado, going from there, from a product portfolio to a semiconductor roadmap, that leads us to the kind of chips that we think and the kind of semiconductor silicon chips that we think that we will be utilizing and needing a lot in the next years, right? So I just mapped them quickly. Robotics, we have sensing ICs, motor controls, edge processors. On the IoT side, we have ultra-low power MCUs, MEMS sensors, industrial connectivity, obviously RF chips, and secure crypto hardware and whatnot. What I want to say here is the point that I want to make is that we're looking at the silicon, at the industrial silicon strategy as a derivative of the product strategy, as a derivative of the demand that we're seeing on the ground, right? So this is the last slide, but I have a couple of things to say beside the slide. I'm not gonna, why localization matters. I think, that was mentioned like 3, 4 times already this year. This year, sorry, this today, right? Um, however, comment on something because I made a point of not putting the word AI in the slides, right? Because I think you showed a slide with the electricity, right? The three revolutions: electricity, and then what was it? Internet, and then AI. Because we do believe that AI is the next electricity, right? 140 years ago, Edison and Tesla were slugging it out in the current wars, and everybody was talking about electricity. Nobody talks about electricity nowadays. It's everything, and it's in everything. So we think that AI is going to be embedded in everything, which takes us to the point that it doesn't make a lot of sense to mention AI explicitly because we can't build a robot without AI. We can't build a gateway without AI. We can't build a sensor. We can't build any industrial platform today without AI. So that's why we took it out, not because we don't believe in it. It's just because we think that it's nonsensical to do it without AI anyway. So that's the first thing that I want to say. The second thing is we're looking at a couple of things that are pretty interesting, maybe as an outlook. One of them is things that we think that's going to, drive a lot of change in the next years. One is the different architectures, right? So right now we're very heavy on the transformer architecture. That's the one that kind of like proven that it can do a lot of stuff. But there's a lot of work on building different architectures. I think I'm personally following Jan LeCun, which was like the ex AI chef of Meta. And he's looking at architectures from a physical perspective also. Can we build architectures that actually understand the physical world? And because we're focusing on industrial use cases, so this is something that would affect us really quickly if something comes up. So this is one thing. The second thing is, and I think also a lot of people today mentioned, the hybrid architectures and solutions. That's something that is we're actively looking into because we go on the ground to customers, talk with them, and then we realize I can throw around fancy words like, okay, this is edge, this is cloud, but at the end of the day, every customer have their own requirements. And from there on, we're looking at how to build the best architectures when it comes to a solution architecture. So a solution architecture is something that is really in our DNA, how to build the best and optimal solution architecture for our client, how to build that in a scalable way. So we're focused on the client and the customer demand more than on what is fancy or what is going on. If I can solve it even with a PID microcontroller, I'm going to do that, right? So that's the second thing. And the third thing I want to mention is we think, and that's maybe very futuristic, but I don't know if anyone's following also the line of research going on, between Japan, Switzerland, I think, and America. There's a lot of research labs right now building the next generation of, I wouldn't call silicon, but compute engines, right? With very using organic material. If you look at the human brain, it consumes for the same compute, it consumes, orders of magnitude less energy. So I think this whole boom is gonna result in, I think in 3, 4 years, in a point where we actually develop technology that allows us to compute a lot more with a lot more efficiency, a lot less, energy consumption that we have right now. So, and the last one that I want to say is, again, as I mentioned, I think Dr. Navid on here, I just confessed to everyone that I'm not a semiconductors guy, but I read this book a couple of years ago. I don't know if anyone read it, The Chip Wars, right? Yeah. So if you haven't read it, I highly suggest that you read it. I looked up yesterday night, I looked up the stats in the book, because in the book it was saying that China is importing, the biggest import that China had in 2022 was chips. Right? It's importing $250 billion worth of chips. Right? And I wanted to check that number again yesterday, and I realized that now China is importing less chips and actually exporting more chips. So I think that's a testament to how to build a strategy, trying to build a strategy, and actually went forward with it. And I think the whole theme of this forum today is how to build the same strategy here in the KSA and move forward with it. So if you haven't read that book, I highly suggest you read that book. It reads like a thriller, so you're going to be done in a weekend. I promise you that. And yeah, thank you very much.